So let's talk about an overview of the RECOVER DSS, that's Decision Support System. And I like to set a lot of these things when I'm teaching, and my students will vouch for this. I like to set things into what I call a historical context. And to set this into an historical context needs a little bit of understanding of what the GIS Training and Research Center, or what the GIS Center, is all about. The mission of the GIS Center here at Idaho State University is to facilitate sound decision-making through the use and application of geospatial technologies. That's what we've done since 1998. And we've focused a lot of our efforts and our whole research program on land cover change across the Intermountain West. There's three primary drivers of land cover change, and it doesn't take too much research to kind of figure that out. But the three primary drivers are, number one, wildfire, number two, invasive plants or invasive weeds, and number three, grazing. And you can also think about it that there's an interaction between those things. We've seen that in our research, and I'm sure you've seen that in your research and your experiences as well. But of course, we're going to be focusing on wildfire with the RECOVER DSS. Wildfires are not only predicted to increase in frequency and size over time, fires are actually increasing in frequency and average size over time. Now, these two graphs were put together by one of my students who's actually sitting in the room. And what we're looking at here is along the x-axis in both cases, we're looking at the year of a fire. And this is from our Historic Fires geodatabase, and it contains all documented fires from 1950 through, right now, through 2017. And these were acquired from GeoMac and InciWeb and so on and so forth, and put all together. And what we're looking at here on the left side is the frequency of fires from 1950 essentially through present. And on the right side graph with the blue columns or blue bars is the acres burned. In both cases, we're seeing an overall increase trend in those fires. And specifically, when we fit a line to it, the line of best fit, unfortunately, in both cases, is an exponential line of fit. And that's not good. I mean, it really isn't following truly an exponential growth curve, but the line of best fit is exponential. And we're seeing an R-squared, or a correlation coefficient, of about 0.75, 0.76 in these things. So it's a pretty significant correlation that we're seeing here over time. Now, of course, we could caveat that just kind of quickly and say that, you know, some of the fires way back here in 1950 may not have been so well documented as they are today. That's, I'm sure, true. But nonetheless, even if we look at the recent trends from the 1980s or 1990s, we're still seeing that overall increase in fires, fire frequency, and fire size. So the take-home message with that, the concern with that, is there's more fires to deal with, lots of larger fires. When we look at the average and the median size of fires, we're seeing more of these mega fires happening every year, more fires above 100,000 acres or so. And yet, you all have the same amount of time to prepare your post-fire management plans, ES&R plans, and BEAR plans and such, on a more or less static budget. So one of the things that RECOVER was designed to do is to help you acquire the data to understand what has happened with that fire and help you make those decisions on how to rehabilitate that landscape following the fire. RECOVER was designed to help answer questions regarding reseeding. Where should reseeding treatments happen? What about mulching, debris flow probability, long-term recovery, monitoring, those sorts of things? You know, for these types of questions, if we think about these types of questions, geospatial data are critical to affect that well-informed decision process. These are really spatial problems that we're talking about right here. Recover capabilities. I'd like to talk just a little bit about that. What you're seeing on the right side is a screenshot of the user interface of a Recover web map. We're going to be using this quite a bit throughout the afternoon. Recover enables very rapid assembly and delivery of geospatial data. Right now, we offer and provide 26 what we call base layers. And these are the geospatial layers that have been most commonly requested by fire managers, land managers, essentially users and partners with the Recover system. You access all of this via a web browser, normally with a username and password that should be sent shortly. But the exercise that we're doing today does not require username and password. We pulled it out of kind of behind that the secure area, so you can get at this exercise and don't have to worry about username and password today. And in fact, this exercise will remain outside the username password area, so you can do your exercise next week, next month, whatever it happens to be. You can also download the data, all the data that you're going to look at on the screen and with the user interface. All that data can be downloaded by just 2 clicks. You'll click up on the menu right over here. It'll drop out. You're going to click data download. You've got it. Nice zip package comes down. And there's also numerous reports at your fingertips. Those same reports we're going to look at will also be available, or are also available, as part of that same download, along with the geospatial metadata describing all that data. Here's a list of our base layers that we're currently providing. I believe that's all 26, maybe showing 25. We just recently added another one that I'm not seeing on the list. It's called Ecological Resilience and Resistance layer. And we're going to actually be working with that as part of the exercise. You'll see that some of these are geodata-based polygon feature classes and GIS lingo. Some of them are rasters. The beauty part of Recover is that using that user interface, the web-based user interface, does not require that you really know anything about GIS. Just work with that data, the stuff that's displayed to you, use it as you wish, and then if you want some more sophisticated spatial analysis completed, then you'll download it. You may hand it off to a GIS analyst in your own home office. You should also notice that these base layers are derived from authoritative sources. We see a lot of use of data from the USGS, from the BLM, from NRCS, the Land Fire Program, and so on and so forth, as well as NASA. The reports that we offer, there's a number of different reports that every fire will have available. That is the general summary, and this is just a one-page report, and these are all in PDF format, of the number of acres burned by that fire, broken down by agency. So, X number of acres burned on BLM land, X number of acres maybe on U.S. Forest Service lands, state lands, private lands, and so on and so forth. The interesting thing, whenever I look at those things, even the smallest fire we have ever run, 384 acres. That's it. 384 acres. Even that burned across multiple jurisdictions. There was some BLM land. There was a little bit of, actually a fair amount of private land, and maybe 50, 60 acres of state land. So I'm sure you guys are very, very familiar with working with that sort of a situation. And what we've also seen is that Recover, one of the advantages of Recover is that you can share this URL with whoever you want to. I mean, as long as they'll have the credentials to view it, and that's just fine that you would share that, or ask me to provide a person with those credentials. Let's talk about some of this additional data layers that are available. The first one I'll talk about is this long-term monitoring. And what we've done here at the GIS Center is working again with NASA Goddard Space Flight Center, we have acquired and we maintain a library of MODIS, what's called MODIS NDVI composite data from 2001 all the way through 2017 right now. And as we move closer to the 2018 fire season, we'll start and go into the growing season, we'll start acquiring the 2018 data as well. So that's NDVI imagery for the entire western United States every 16 days throughout that 2001 through essentially present time period. From 2001 through 2017, all of that data is used to calculate the long-term average. And in this chart that we're looking at on the right side, average is shown in the blue dashed line. Once we get into a new fire season, let's say once we move into 2018, we start calculating, and this one of course was screenshotted from a 2015 fire season. What we're doing there is we're taking that particular growing season and calculating its NDVI average and comparing it to that long-term trend. And as you can see in 2015, for this specific area, which happens to be from the Pony Fire in Idaho, that we had higher than average NDVI. Well, what does that really mean? It means higher than average photosynthetic activity or higher than average biomass production. In other words, more fuel. Once the fire occurred, of course, we see that drop. We actually expect that because the fire burned that vegetation, and there's going to be some vegetation inside the area of interest used to calculate that, where there is still some vegetation, so it doesn't just drop out to zero. But we do tend to see that get lowered because we're looking at averages across that fire area. So if you're requesting long-term monitoring, you'll get this graph in a report format. You'll also get map layer data that's automatically added to the RECOVER user interface, and you can query it and work with it right there. The second graph that comes out of the long-term monitoring just looks at the same information a little bit differently, where we have used the average to normalize that data. More or less, we make the average at 0, and then we look at that departure relative to the start date, and that can be very useful as well. Now, you might look at this and say, well, why did NDVI drop just before the fire? Well, maybe it didn't. And the reason why I say maybe it didn't is because this line here is drawn on the day that the fire officially started, or officially was reported as started to us. But remember, these are 16-day composites. So when you get really, really close like this, you know, maybe this drop was really right over here. Okay, so don't get too worried about this sort of thing. I tend to look at these things as these trends relative to the average, and then we expect to see on this side of that orange vertical line, we expected the NDVI to have dropped below that blue average. How does RECOVER work? How does this all work? Well, first of all, we're going to have some sort of fire ignition. Some sort of fire event is going to start occurring on that landscape. And you as firefighters, as fire managers, land managers, are going to go into that mode of gathering data. You're going to be trying to suppress that fire and deal with that fire and all the things that go along with it. And one of the pieces that happens, the data that gets gathered, is the fire perimeter. Polygon, usually a shape file, gets put together for that fire's boundary. Once that's available, you, as a user, a partner end user of RECOVER, can take that shapefile, just zip it up, or have your GIS analysts help you out with this. It's really quite simple, as you're going to see. And then you use what we call our RECOVER generator. Looks like a normal web map when you navigate into this and log into it. And all that you do is you're going to upload that shapefile, give the fire a name, put in your email address. If you want some of these additional data layers, let's say the DNBR, fire severity in quotes, or fire affected vegetation. If you want a debris flow likelihood or probability model, if you want the long-term trend data calculated for you, just check those little boxes and then click submit. And literally in 5 minutes, you're going to receive an email that looks just like this, thanking you for using this. And then right up front here, that is the URL to launch your brand new website. Now, earlier I showed you the RECOVER web page, the project web page, and maybe before you go to the generator, what you could do is check if it's already been run. That's something you can do. You don't have to do it, but you can do that because it might already be done, and you can save even those 5 minutes. All this stuff happens with a tremendous amount of automation on our servers. Ultimately, what you get is this fire-specific web map, and that's where we're going to be spending the majority of our time this afternoon. So when you first launch this is what you get. You're going to see exactly this. Well, a splash screen will come up, and you'll click into that splash screen. It has some of the credits and so on and so forth. But this is what you get. And this layer list and legend is one of the first things that really greets you. But before we even jump into this, kind of disabled looking is this navigator bar. This one is really, really handy. You'll see that it kind of disables itself, fades out when you're not using it. And as soon as you move your mouse cursor back into it, it darkens up and fully colors up, and you can make good use of it. If you want, you can zoom in using these tools, using the slider bar, whatever you like. You can also use these zoom in and zoom out tools in a very, I think, very user-friendly and intuitive mode. It's one of these deals where you click on it and then you just drag that rectangle, and it really is highlighting the area that you're going to zoom into and kind of darkening up the area that you're going to zoom out of. Okay, once you're done with that, you can go back to the pan mode, which is automatically enabled for you. Move the thing around wherever you like, viewing this thing as you go. If you accidentally move this stuff too much, and maybe you lose all of your map area, and you can't even find how to get back to it, which does happen, especially if you're working on something for a while and you come back to it. Just click on the full extent once again, and it comes back to how it first launched when you first entered into this decision support site. Similar type of thing, you can go to the previous extent and next extent. This is sort of like your backwards and forward browser buttons. Go to the previous URL page, the next URL page, and so on and so forth. So those are kind of very useful. You can incrementally pan to the right, to the left, and so on and so forth. And you can play with this, and I'm going to encourage you to do that as part of that exercise. Now let's turn our attention to the layer list and legend. The very first three that you see are turned off. In fact, most of these layers are turned off by default, except for those RECOVER base layers. But the first three that you see are real-time field records of some sort. And as we go through this layer list and legend, whenever you see these little arrows, arrowheads to the left, you can use it to expand, to look at the legend. Some of these groups have subgroups inside of them, and clicking it will reveal what those are. Okay. Now, unfortunately, this fire does not have any real-time data streams recorded for it. So in many, many cases, you're not going to see any data. You're only going to see data for these things if there's data that has been recorded for these collector for ArcGIS applications. Again, I'll kind of throw this out too to get the fire community thinking about it. If there is a real-time, collector for ArcGIS type of app that you guys are using that you'd like to see integrated into RECOVER, this is so easy for us to do if we have what's called the REST endpoint. Essentially, it looks like a URL. We can replace any of these or all three of these with that information or with that data stream that you guys have. It's really easy for us to do that for you, and be more than happy to do that and help make this information available to you in more or less real time. Yeah, Lori, as long as we have that REST endpoint or some sort of it could be a SOAP endpoint as they call it also, as long as we have that URL, yep, we can bring that right in. Yeah, I thought Forest Service was working on some of those surveys, so let's talk about that and see if we can replace any of these real-time apps that are kind of not being used too much with the ones that are being used more so. Got another question here from Frank asking about Avenza. One of the things that we experimented with last year is by geo-PDFing some of these layers and making those things available to Avenza. If that's of interest, let's keep talking about that as well to see if we can make that available to you to help you with your decision process.
Awesome, that'd be great. Thank you.
Can we consume data coming out of Avenza? I would think we can, and I think we can. I don't know it because we haven't tried it. We do an awful lot of experimentation here, and it's kind of more or less when there's a will, there's a way. We try to find it. So based on how that data is structured coming out of Avenza, we should be able to get that consumed into RECOVER. Yeah, another question here is how do we handle areas that do not have an official NRCS soil survey? Those areas will be blank. There may be a blank polygon there. And so we have, as you're going to see here in just a little bit, we have two different soils layers that have been made available. One is the Surgo, that does not have 100% coverage throughout the western United States. It's covered 100% in RECOVER by blank polygons. A polygon to say there's no soil survey here. But StatsGo does cover it, and we make that available for those instances where Surgo is not available. So that was a good segue into looking at these RECOVER base layers. By default, the fire boundary is turned on. You'll see here that we have roads layers, and they're just as simple to turn on by clicking the button to display them, just like that you would do inside of ArcGIS or ArcMap. Turning them on, turning them off, and you see that they respond, or RECOVER responds very quickly to show you that. NHD is the National Hydrography data set, showing you all the surface water, streams and rivers in that same AOI, which is a rectangle in this case. Critical habitat areas, wetlands from the U.S. Fish and Wildlife Service, National Wetlands Inventory, PLSS, Public Land Survey System, showing you all those section lines. SMA is Surface Management by Agency. I'm sure you're all very familiar with that. Some basic geology layers, USGS Watersheds Boundary data set. There's our Surgo layer, our StatsGo layer, a specific StatsGo-based K-factor layer, USGS landslide potential, historic wildfires. I'm turning that on to see if there has been any fires in this same area that have occurred prior to this individual fire. We're seeing a couple appear here. One that was a burn-on-burn type of effect, where the we're calling it the exercise fire, burned over the top of this other fire that we'll take a look at here in just a little bit, how to use these identify tools and learn more about those previous fires. We have a raster layer that looks at the historic fires, but just those historic fires that have burned in the past decade. And what we're seeing here, whoops, I'm gonna, yeah, there we go, is that we have some, let's see, do we have any fires? We have to look at this a little more closely. I'm not so sure if there's been any fires in the past decade. Some of those other historic fires might have been earlier than that. Oh, I should also mention to you that, you know, a lot of folks do like to take a look at this aerial imagery as the base map, but in some cases, it may be hard to discern some of the other geospatial data. So what you can do is simply go over here to the base map, what's called a widget. All these things are called widgets, and turn on something different. Maybe you want to turn on National Geographic, or the topography, or just go back to the world imagery. And as you can see, they update very, very quickly. Then we get into the new layer. This is called the Ecosystem Resilience and Resistance layer. This is one of them that we did not have available to you in 2017, but is now available 2018. And this is displayed to you as high resilience, moderate resilience, or low resilience following a disturbance, and specifically in this case regarding or related to wildfire. There was a question earlier about land fire. These are the land fire layers that we have available. Fire regime group, BPS, biophysical setting, environmental site potential, existing vegetation cover, existing vegetation type. If there's others that the fire community says this is really, really useful land fire data, just let me know. You'll get my email. You already have my email most likely, but you'll get more from me following this workshop. I'd love to know this because Recover is definitely client-driven, client-centric. I could think about probably thousands of, oh, this would be cool to offer this. I bet you they'd like this. And we could fill up this layer list with lots of stuff, and you might look at it and say, junk, no good, I don't like it. So we're not going to do that. We're not just going to guess. I mean, I might have some ideas, and I'll ask the community, what about this, what about that? But if you don't want it, just let me know, and it won't happen. But if you do want it, you do need it, then we'll try to make that happen to help you out. Got another question here coming in on the chat line. The 40 Scottenbergen fuel model. Okay, I'll have to take a look at that to see if I can find that particular fuel model, land fire layer. The measure for resilience, yeah, so that fuel model is part of land fire, right? So we will have to revisit that land fire program site and see if we can find that data and make it available. The measuring for resilience, again, we don't really produce the data that you're looking at. We get this data from authoritative sources, make it available to you in what I call a geospatial context. So everything lays over the top, overlays perfectly. You don't have to worry about projections. You don't have to worry about data formats or anything like that. So we've done all that legwork for you. And what we're going to see here is that this ecological, what I call the R&R layer, is based principally on soils, precipitation regimes, as well as, I believe, the topography variables been taken into account as well. And we'll jump into this and take a look at all the different data that's available in just a little bit. And I know that, I believe, Doug Havlina is on the line. And Doug, if you wanted to say anything about the production of the resilience and resistance layer, please let me know, and I can make sure that your mic is turned on, or we can just deal with that later on. Oh, there we go. Carla, there's an answer for you. Okay, so I'm going to keep stepping through these 26 different layers. You know, one of the things that we were asked to do not too long ago, I believe it was about 3 years ago, was to instantly delineate places that have steep slopes. So the magic number that we were told was 30-degree slopes. And so what we did is we created, I called it a highlight layer when we first made it. And this highlight layer shows you all those places in your area of interest where the slopes exceed or are equal to 30 degrees. And in that case, as I understand it, on fire suppression, firefighting efforts, those are places where that's more or less on foot fire attack only. No tracked vehicles, no wheeled vehicles. And it also plays a role in post-fire debris flows and erosion types of concern. So we made that for you folks a couple of years ago. And that's one of the 26 base layers that's available to everyone. Then we have elevation, aspect, the direction that a surface faces, a hillshade, which is a nice way to visualize kind of the three-dimensionality, the topography itself. Slope presented in degree and slope presented in percent. That wraps up the 26 base layers. I'm going to roll this up. Next, I'm going to look at this NDVI departure. And I just turned it on, but you're seeing nothing is showing up. And when we expand this, you'll see that the layer itself, NDVI departure from 2017, when this fire occurred, is shown in italics. That means that we're zoomed out too much for the scale threshold that this has been built at. So if we zoom in just a bit, it turns itself on. Now this is based off of MODIS pixels, so they're relatively coarse, 250 meters per pixel. But what it is showing us is those areas where the NDVI was far less than the mean, all the way through pixels where the NDVI, photosynthetic activity, biomass production, was far greater than the mean. So the majority of this fire was covered in areas that were far less than the mean, which might indicate that there was less biomass than what you'd expect in an average growing season. I said average in my quotes with my fingers, right? Because as a scientist dealing with natural resources, we often question what is average, what is natural, and so on and so forth, because the world is always changing. And every year really seems to be a little bit different than another. The debris flow probability layer. This one is from the USGS landslide hazards program. This is displayed to you as debris flow prediction based on a rainfall event of 24 millimeters per hour. It roughly equates to a 1/4 inch of rain per hour, that sort of event. And the probability of a debris flow is shown from high, moderate to low. Concern areas are these right over here. Lastly, there is the fire-affected vegetation layer. And what we're seeing here, again, I'm just expanding this and looking at that legend. The highest, if you want to call it fire severity areas, are shown in the darkest of red. We have some of those areas right here, a little bit over here, some there, with low fire severity shown in the greenish colors. And some of these places, when a person visits in the field, takes a closer look at it with field observations, you might find out that they were unburned entirely, or such a low burn that you're not going to be concerned with those things. And I should mention, that RECOVER is a fantastic tool, very quickly getting you information, puts it all into a geospatial context, makes all this geospatial data and the reports that we're going to look at a bit right at your fingertips. But it's never meant to completely eliminate field work. You have to use all of the information at your fingertips available to you to make those well-informed decisions. You can also use RECOVER to help guide where you're going to visit in the field. This was a fairly large fire, and on these larger fires, especially once we get into hundreds of thousands of acres, the ability for you to visit every little chunk of ground is more or less impossible. But what you can do is you can guide your field visits by saying, I want to visit this place and I want to take a look at what's going on right around here, whatever, those sort of things. So that's another place where I know GIS and specifically Recover have been used. Okay, now, so far we've just been looking, visually kind of taking a look at this thing. And so that's more or less what you would get with Google Map and Bing Map and those sort of online maps. But Recover gives you a little bit more, fairly more than that, to do a little bit of interrogation or analysis when you're looking at all this stuff. And we can do this using the identify tools. So I'm going to start up that tool, and whenever we start up one of these tools here right across our menu or our toolbar, I always say that we launch the tool and then we set up the tool. So this is the identify tool. Use the identify tool to identify features on the map, and we're going to ask it to identify from, well, let's see what we're interested in. Let me go ahead and specifically turn on, because there were some questions about this, ecosystem resilience and resistance. So that one's turned on so you can see it. And we're going to find ecosystem resilience and resistance here. And I'm just going to click. Okay? So this tells us that the RR class name, its resilience, is high. Its common name is cold and moist. We click over here. It's a moderate class. It's a cool/summer, moist bordering on dry. And there's more data behind this, tremendously more data behind this, and you'll be able to get at all that data by doing the data download that I'm going to show you here in just a little bit. Another thing that we talked about a little bit earlier was to kind of look at these historic fires. We saw that this fire, there was a fire that was a burn-on-burn type of effect. It looks like it was older than 10 years because the same fire did not appear in our past decades raster. So let's see if my hunch is right. I could have just left that identify tool running. Didn't need to close it out like I just did. We're going to now query the historic fires layer. Click it. It was a 2009 wildfire. So what, did we just miss it, Jonah? Yeah, I guess so, because this is all built off 2018. Yeah, right, so we just barely missed it. We built this exercise site for you just recently. If we had looked at it even just a year or so ago, if this fire had occurred, you would have seen that this same fire would have also appeared on the historic fires since the past decade. So very cool. I'm going to go back to this thing. Click it. It was called the Horse Valley Fire that burned, you can see there, 2,563 acres. The soil Sergo layer is kind of interesting. What we see here is that what was already suspected is that, on Forest Service lands, some of these public lands, there's just not a soil survey that's been done. Some of these areas here, there is some soil survey information that's available. Again, using the identify tool, I can find out some more about this. Click on one of these, and what you're clicking on does not have to be inside the fire perimeter. As long as the data appears, you're going to be able to see it, query it. And this one has a URL linked to it. I'm going to click on this, and I already know what it's going to do because I can see the type of report it's going to pull up. And what you're going to get is you're going to be told that an ecological site report has not been created for this. It's not available through this USDA NRCS. In fact, in the exercise fire area, no ecological type reports have been created. We do not see any of this kind of coloring, this tan color where a plant association report is available. It all looks like this kind of grayish color. No additional reports are available. But I wanted to show you another demo site that we have put together. And this is the Crystal Fire, Idaho, burned in 2006, about 250,000 acres in size. And I wanted to show you this one particularly because it does have soils Surgo data available. Some of it is not available, just like we saw earlier, but other places do have Surgo data available. And so I wanted to show you this so you know what these ecological type reports are going to give you. Same thing, I launched the Identify tool and I'm setting it up now. Soil Surgo. I'm going to click on one of these of interest. It highlights that was a large polygon of soil association. Click on the same URL, this little link launcher here. There we go. And we see this ecological site plant association vegetation report that we've pre-generated. Wherever they're available, we've pre-generated them. They're sitting on our servers, ready for your use. Soil association type, the name, quick description, the characteristic vegetation that was found in this site, obviously prior to the fire. If you go through and you need this data, just so simple, any others, just like any sort of PDF, just download it. It's now on your machine and you got it. Back to our exercise fire. One of the tools that I wanted to show you is some of the display stuff. So, so we're looking right now. I'm going to turn one thing off. Turn on fire boundary once again. Turn off the soils. Okay. Whoops. I wanted to turn on this hillshade. Okay, well now what's happening is, like in any sort of GIS, this layer list draws from the bottom to the top. So we cannot see the fire-affected vegetation because it's drawn over by the hillshade. But you might be like, well, I want to see this on top of it. Well, you can do it right here. You don't have to dump it out to an ArcGIS or something like that. You can do this sort of visualization work right here inside Recover. We're going to click, move it up. You got to do this a few times. Move it up. Goes one step at a time. Now you see it's being drawn over the top. Now another nice thing that you might want to do, you might be interested in zooming into some of these areas. And now you might be wondering, well, what's the interaction here between some of these higher severity areas and the underlying topography? Gee, wouldn't it be nice to take a look at all this at one time? A couple of ways to do that. One is we can adjust the transparency of this particular layer. Let's bump it to about 50%. Now what you're starting to see is you can see this topography underneath it. We can clearly see a ridge line following right along here. Maybe this is a valley bottom, some more ridges, hills coming up on this side. The other way to do this, I'm going to go back to 100% or 0% transparency. And the other tool I wanted to show you here is called the swipe tool. Another way to help visualize that data and get a feel for what's going on the landscape as a result of this wildfire. I'm going to launch that swipe tool. I need to set it up, so I need to choose the active layer. What am I swiping away? Okay, what am I peeling away? And what I'm going to peel away is the fire-affected vegetation layer. I'm going to use this swipe tool. And when I move my mouse cursor into the map area, away from the tool itself, you'll notice that this black-headed dark arrow appears. And when I press it, notice how it kind of lifts off the fire-affected vegetation layer and lets us see whatever is underlying it. the next layer that's being drawn. The spotlight tool works very similarly, except, it kind of works like this, where you're just spotlighting things away. Both of those things can help you visualize the data. Personally, I like the swipe tool. That's just my own personal preference. But I want to make sure that you are aware of this tool and how to make use of it so you can make the most out of Recover. I should also note that this inset right over here kind of gives you an idea of where we are in the wide world. If it gets in your way, you can just knock it down. Okay, get it out of your way, open it back up, and so on and so forth. Graphics tools. We're going to have you work on that as part of the exercise. I'm looking at our time here a little bit. I'm going to jump into our question and answer session here in just a little bit. But we are going to be making use of the draw and measure tool. It's a really very handy tool to utilize in Recover. Get a quick estimate of acreage of something that you're interested in. And we have a little scenario to work on as part of that exercise. You can bookmark different parts of this web map, the way you're zoomed into it and what's being shown at this time using this bookmark tool. You can import your own data. So let's say that you have let's say you have a shape file on your machine. Relative to this fire, you want to display it on your screen. You can simply use this import shapefile tool, load your local shapefile. It's just a zip file. Load it up, and it's going to open, display. There has to be a projection definition for it. It'll reproject as necessary for you, and show it right here on the screen for you. And you're ready to work with it. Now, your data will not be available to everyone else, though. If you do that import a shapefile, that's for your use right here, right now. Someone else down the hall, someone else across the country, whatever, another person using Recover, even at the exact same time you're using it, will not be able to see that. So just so you know how that thing works, it can be very handy for you, but the limitation is that no one else sees it at the same time you see it. You can print your maps if you really like what you've got here. You can print this thing, give it a title. There's some layout templates that are available. There's a BLM template in landscape format, a BLM template in portrait format, generic GIS Training and Research Center. And if you have a template that you like to use, you can send that to us and we'll get that built right into Recover. That step is pretty easy. I like to put my stuff out as PDF. We'll tell it to print, and it's going to generate this thing. May not look too beautiful right now because it's more or less going to be a screenshot of where I'm at right now, but give you an idea of what it's doing and where did it put it.
Wouldn't you want to open that legend for the printing?
Yeah, there's lots of things. You can set up this, make it look this way, that way. But it'll interrogate an awful lot of stuff. It won't show the layer list and legend. It's just going to show the data. And based on the template that you're using, it will look different ways with each template. Okay. I got to find where it put it. Nope. Unless it's still working on it. I want to jump in here before we go into the question and answer session and then jump into the exercise. Wanted to show you this menu over here because we looked at really geospatial data, lots of geospatial data, but there's other data available to you here as well. One is the reports. And the first page of the report, again, gives you the summary. And it is showing you that 789 acres of this fire were on BLM land. The great majority was Forest Service land. Almost 72,000 acres burned in total. Then as we scroll down here, page 2 is your summary of ecological resilience and resistance. We're seeing high resilience, 57,000 acres, moderate resilience, 3,181 acres, and that same almost 72,000 acres is your total. Now you might be saying, hold on a minute here. You said it was 71,688 acres. Now it's saying it's 71,696 acres. This value here is calculated from the raster data, which is the ecological resilience and resistance layer. This here is generated from the vector data, which is that ultimately it's from the fire polygon that was uploaded. So this is probably the more accurate of those two numbers, but they're in the same projection in both cases, if you're wondering about that. Starting at page 3 and on for however many pages is required, we get into the soils information. So here we have Utah 634 area symbol. This is based off of soils Surgo data. On the Bureau of Land Management has this breakdown of map unit symbols and these acreages for each of those. Forest Service, the same breakdown. Private lands, state lands, and so on and so forth. These pages here, starting what's this, page 5, I believe, and 6 is that long-term NDVI trend that we talked about a little bit earlier. And then the balance of the pages talks about in detail how to use that and what you're really looking at when you're looking at and dealing with that debris flow model from the USGS landslide hazards program. All this data that you're looking at, from the 24 millimeters per hour that we had displayed, as well as 12 millimeters, 16 millimeters per hour, 20, all the way through 40 millimeters per hour, all that data is available to you by clicking the data download. Okay? So you click on the data download and it instantly starts that download for you, just like any other download in a zip file format. And while that's finishing up, I guess it is finished up faster than I can talk about it, you can always contact us. Oh, I guess this computer isn't pre-set up to know what to do with a mail me type of thing. But you know, most desktop, this is an instructional machine, will automatically launch your browser, your selected email application, and get that set up. This one doesn't have it, but you could actually steal it right here. There's an email that'll get to my whole team at the same time. That's recoverdss@gmail.com. Okay, let's open the floor for question and answer. Does the fire perimeter, question here regarding, does the fire perimeter and other layers have metadata that identifies when it was created and generated? Yes, it does. And the best way to take a look at that metadata is with the data download that we just completed. And since we have actually just done that, I will minimize some stuff and show you what we got. I'm going to tell it to extract. I like to tell it to extract a folder. This automatically kind of sets up a nice storage mechanism for me. I can look back and it'll say, you know, Exercise Fire Utah. There we go. I go into this thing. There's all the reports that we just looked at. You have everything right there already downloaded for you. Data, a metadata folder. And there we go, metadata, aspect, geology, habitat, so on and so forth. And so if we just click on, let's just click on the top one here, I guess. This is it. You're looking at all this data. It tells you, you know, just normal FGDC compliant geospatial metadata, when the thing was created, last updated, and so on and so forth. This one in particular, its revision date was a couple of years ago, 2016, November 14th. And every one of these will have this sort of information for you. We do go through, once the fire season ends, normally about October until about April or May, we here at the GIS Center are working on updating new base layers for the coming fire season. We're going to be, or we are acquiring new MODIS data to support the NDVI long-term trend and so on and so forth. And as we change that data, as we update it, like we did for the PLSS layer this year, there were some new areas available with updated section lines. You're going to see that metadata reflects those changes. So there's a number of layers this year that have been updated, and you're going to see revision dates of sometimes late 2017 or early in 2018. So we keep the geospatial metadata updated just like we keep the geospatial data itself.